Hey guys, Mr. Wilson here. Today we're going to look at the distance and midpoint. At the end of this video, you should be able to use the distance formula to find the length of a segment in a coordinate plane, and you should be able to use the midpoint formula to find the coordinates of the midpoint of a segment. Okay, so we kind of talked about segment lengths already in lesson 3 using the segment addition postulate, but what happens if we see the segment on the coordinate plane? Okay, so we're going to jump straight into an example here. And our example asks us to find the exact length of AB, okay? And then round your answer to the nearest tenth if necessary. So in order to do this, we can't really just like count. Some people try to do that, but the distance from here to here really is unknown. Like horizontally and vertically, we can see 1 unit, but when it becomes anything other than that, we would be guessing at its length. We really don't want to guess. Math is a specific and what's the word I'm looking for? Exact science. There we go. Math is an exact science. Okay, so we want to be exact as possible. Okay, and so in this case, we can't really use a segment addition postulate. It doesn't apply, and so we need to find another way to find length, and this is where we use the distance formula. Okay, now it's a formula, but don't get overwhelmed here. Here is the formula. We'll write it down, then we'll talk about it. So the distance formula is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and with these 2's and 1's, it's just denoting that it's the x from the second point. It's the y from the second point. X from the first point, y from the first point. Okay, so it's not like squared or anything like that. Okay, there it's square up here. Okay, I'll show you how the distance formula is really the Pythagorean theorem in hiding. They asked us to find this length using our formula. I am going to plug in my values. And I like to organize myself. So I organize myself. I have x1, y1, x2, y2. So I'm going to do x2, which is 2. I did it right. Minus -3, so that's plus 3. Squared. And that'll be plus y2, which is -3, minus y1, which is 4. Okay, now I'm going to go through and just simplify. 2 plus 3 is 5, 5 squared, and then here I'll have -7 squared. Important to keep this in parentheses here, especially if you're using a calculator, because if you take this outside of your calculator will tell you -7 squared is -49, but you know you have it in parentheses. It should be a positive number. Negative times negative is positive. So here we have 25 plus 49. That gives us what, 74? So the distance, this is our distance formula, right, is radical 74. Make sure that seems like 2 and 37. Yeah. So we can't really break that down anymore. So here, the exact length of AB is radical 74 units. Round it, my calculator, I'll take the square root of that, 8.6. Okay, now here's what I want to show you, because I said, hey, this is really just Pythagorean's theorem. When we're on a coordinate plane, it's pretty simple to see that the distance formula is Pythagorean's theorem, because what we're doing, because we talked about length already when we did segment addition postulate, when we look at our triangle, what we're doing by taking the difference between the x's, right, -3 minus 2 or 2 minus -3, is we're seeing how far left and right are these from each other, okay? And so when we do -3 minus 2 or 2 minus -3, we find that this distance is 5. Okay, we do the same thing here with the y's from 4 to -3, -3 minus 4, or 4 minus negative 3, we find that this distance is 7. And so what we have is a right triangle. We're using a squared plus b squared gives us c squared, where c is that distance, that hypotenuse. Okay, and so really we can do that to kind of save ourselves some time if we like. You'll notice that these numbers that we found, 5 and 7, are the same numbers that end up being in our distance formula. Okay, so if that's easy for you to understand a little bit easier than remembering the formula, then that's what the formula is doing. Okay, so we can kind of use that here, whether you want to use the distance formula or Pythagorean theorem, either one's fine with me. But take a second, try to find the distance between RT. So here I'm going to say, okay, negative 2 and negative 8 are 6 away from each other, so 6 squared. Negative 1 and 7 are 8 away from each other, 8 squared. That's 36 plus 64, that's 100, right? Pythagorean theorem. So if c squared is 100, that must mean that c is 10. Or RT, I guess is better to see, is 10. So whether you use Pythagorean theorem or the distance formula, they're the same thing really. Our distance is 10. Midpoint. It can be helpful to find the middle of something. For example, if Billy got 60% on the first quiz and 90% on the second quiz, his middle or average quiz score would be 60 plus 90, 150 divided by 2, 75%. Okay, we can do the same thing with segments on the coordinate plane. It is essentially finding the middle or average of two coordinates. Okay, and so here's our formula for it. Basically, we're finding the average just like we did up here, right? So we did 60 plus 90 divided by 2 because there were 2, right? And that gave us 150 divided by 2, which is 75. And so that's what we're doing. With the x's, we're finding the middle. x1 plus x2 over 2. And then we just have to do that same thing here. y1 plus y2 over 2. And that's our midpoint. Notice that the answer for finding the length is a number, while the midpoint, the answer is given as a coordinate, right? And our formula sets it up to be that way, right? It's a coordinate. It should be something x, comma, whatever y is. All right, let's go to a second example here. Let's find the midpoint of this segment. So here we want to make sure that we identify what the coordinates are. So this is 2, 1, 2, 3, 4, 5, 2, 5 here. And this is negative 1, 2, 3, negative 1, 2, 3, negative 3, negative 3. This is asking us for the midpoint. Make sure we use the midpoint. So I'm going to do my x's, 2 plus negative 3, or 2 minus 3, over 2. Gives me my x1 plus my x2, right? Okay, and I'll do the same thing with y1 and y2. So my y1 is 5 plus my y2, which is negative 3. Again, plus negative 3 is just minus 3. Okay, and I just do both of these. 2 minus 3 is negative 1. Negative 1 over 2 is negative 1/2. 5 plus negative 3, or 5 minus 3 is 2. 2 over 2 is just 1. So what's my midpoint? It's negative 1/2, 1. And so as I look and find that on my graph, I see that here's my midpoint. It makes sense visually. Okay, because it makes sense mathematically. All right, a couple more questions. It says QS has endpoints 3, 5, and 7, negative 9. Find the midpoint and then and call it M, and then find QM to the nearest tenth. So they're asking us first to find the midpoint and then find the distance of half of it. So here we can find the midpoint just by plugging in our values in. And again, I invite you to take, you can pause it and try to do this. Okay, so we're going to find the midpoint, and that is going to be the x's, the average of the x's, so 3 plus 7 is 10. The average of the y's, 5 minus 9, which is negative 4. Okay, and so we should see that that midpoint, that point M, will be at 5, -2. Okay, that's our midpoint. And then it asks us to find QM. Okay, so I'm going to use this as Q. This is X1, this is Y1. This is X2, this is Y2. Okay, I can plug it into that distance formula if I'd like, but I think, like I said earlier, thinking of it as Pythagorean's theorem makes it a little bit easier for me. So I'm going to say, okay, the X's are how far apart? Well, 3 and 5, they're 2 apart. 2 squared. The Y's are how far apart? 5 and -2, they're 7 apart. Equals C squared. So I have 4 plus 49, or 53. So C squared is 53, and I can find out what C is by taking the square root of both. And I find that QM is radical 53, but the directions tell me to do it to the nearest tenth. Always read the directions and follow them, please. And so that'll be 7.3. So 7.28, but to the nearest tenth, it's going to be 7.3. So we find out that QM is 7.3. Here is a little bit of a different question. In this problem, they give us the midpoint. They say the midpoint of Kn is 3, 4. One of the endpoints, K, has coordinates of -3, 2, -2. Find the coordinates of N. So let's look at that. We're given a line. Doesn't matter how the line looks, really. I guess I can put like 3, 4, -3, 2. -2 would be something like this. Okay. Okay. Again, I'm just here to draw points. All right. So we're given that the midpoint of Kn is 3, 4, and that K is at -3, -2. All right, they want to know what this thing is, what this unknown point, or at least, I mean, this N. They want to know what N is, what they haven't told us. So how do we figure that out? Well, we already have the formula, but we're going to have to kind of rewrite it because there's not really an equal sign in the formula as we use it, but it's enough information for us to go off of. So as we look, I'm looking here and I say, okay, well, the X1 is -3. I don't know what the X2 is. So I'm going to say plus X over 2, but I know it equals that midpoint 3. Right? Because this is that midpoint. They told us the midpoint was 3. Okay, so as I go through and I solve, I'm going to multiply both sides by 2. I get 6 equals -3 plus X. Add 3 to both sides, and I get X equals 9. So the X coordinate of this point N is 9. And I can do that same thing with the Y. Okay? Again, I know that my midpoint for the Y was -4. Right? Okay, my one Y coordinate that I did know was -3 or -2. You see it here. It's the Y here. Plus Y over 2. Multiply both sides by 2. Get that to be 8 equals -2 plus Y. Add 2 to both sides, and we get Y is 10. So now I see that my coordinate, my point N would be at 9, -2. I just already found the answer, but I want to write it here as 9, 10. Okay, so there we go. That's distance and midpoint formula. Using the formulas, but also hopefully recognizing distance formula as Pythagorean theorem. I think that'll help us out a lot.